I'm going to tell you a story about how a question, a simple question formulated by a student in school, sparked a theory in the mind of a scientist. It is the 18th century. We're in the middle of the Industrial Revolution. John Dalton was the son of a weaver, but he didn't want to follow his father's profession, as was the tradition in those times, and he wanted very much to become a teacher. He enjoyed learning, he enjoyed teaching. And even though he had to work from a very young age, he managed to become a teacher. He was a professor of chemistry. It was just at the time when Lavoisier's quantitative theory of the mass of elements was new, and John Dalton was very excited by this new approach to chemistry. It wasn't just the combinations of elements, but there was a strict and rigid structure, a mathematical way to go about combining the elements. And he was teaching one day in school, telling them about the quantitative theory of the mass of the elements in a chemical reaction, and explaining all this to the students, when one of the students, a young boy named Smythe, said, "Please, may I ask a question?" "Yes, of course. What is it you don't understand?" said the teacher. And the young boy said, "I understand that there is a mathematical relationship, a ratio of the mass of the elements which does not change, but I don't understand why." And it was the first time that the teacher thought of looking for the reason behind this theory. The question stayed in his mind, and for many years, John Dalton thought about this question. He conducted experiments, and he measured, and he started looking in ancient and older chemistry books to find the answer. Scientists were discovering that it works like a recipe. If you combine this amount of this element with that amount of that element, then you get something new, and if you uncombine them and combust them, then you get the same amount back. But it was not until he found in the library a reference to an argument by the ancient Greek philosopher Democritus, who talked about matter consisting of indivisible particles, that he started formulating the idea and the theory of why this happens, not only how this happens. And he combined his thoughts and his theory into 5 truths. The first, atoms cannot be made or destroyed. The second, all atoms of the same element are identical. The third, different elements have different types of atoms. The fourth, chemical reactions occur when atoms are rearranged. And the fifth, that compounds are created by the atoms of constituent elements. When Dalton presented this theory to the scientific community in a lecture, there was great resistance to this theory, but he explained that this theory explains why what they were observing empirically was happening. But of course, there was this voice from the audience that said, "Oh, excuse me, Mr. Dalton, have you ever seen an atom?" And it took more than 60 years after his death for the scientific community to accept his theory.